Okay, let's start by reading the problem description for Fibonacci number. The Fibonacci numbers, commonly denoted f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones, starting from 0 and 1. That is, f of 0 equals 0, f of 1 equals 1, and then here we have the general formula, f of n equals f of n minus 1 plus f of n minus 2, for n is greater than 1. Given n, calculate f of n. For example 1, we have an input of 2 and an output of 1, because f of 1 plus f of 0 equals 1 plus 0. Example 2, we have an input of 3 and an output of 2. F of 2 plus f of 1 equals 1 plus 1, gives us 2. Example 3, we have an input of 4 and an output of 3, because f of 3 plus f of 2 equals 2 plus 1, which gives us 3. For our constraints, we can see that n will be greater than or equal to 0 and less than or equal to 30. Fibonacci number is a well-known coding challenge. One of the more popular solutions you see for this challenge involves using recursion, but the issue with that solution is, without memoization, it has an exponential time complexity. I won't be covering that approach. Instead, we'll go over a more optimal approach utilizing some simple iteration with a while loop. This approach has a big O of n time complexity and constant space complexity. The general idea behind this approach is you only need to have the two previous Fibonacci numbers to calculate the next number. Here we'll diagram an input of 5. We'll start by setting up two base cases. Remember, the Fibonacci sequence starts with 0 and 1, so we can check if n equals 0, we'll return 0. If n equals 1, we'll return 1. Next, we'll initialize a counter with a value of 2 since we already have the 0 and first indice values covered. We'll initialize a sequence array with 0 and 1. Then we'll begin our while loop that will iterate while a counter is less than or equal to our n input. And we'll calculate the next number by summing up the two current numbers in the sequence array. That gives us 0 plus 1, which equals 1. We assign the sequence number in the first index to the 0 index, and assign our next number to the first index. Our counter increments to 3. Now we have 1 plus 1, which is a sum of 2. We assign the value 1 in the first index to the 0 index, and assign the next number to the first index. The counter increments to 4. 1 plus 2 gives us 3. We slide the 2 over to the 0 index and assign the next number to the first index. The counter increments to 5. 2 plus 3 equals 5. We slide the 3 over to the 0 index and assign 5 to the first index. The counter increments to 6, which causes our while loop to evaluate to false because it's greater than our input of 5. So we exit the while loop and return the first index of the sequence array. Let's translate this to code. Okay, the first thing we'll do is set up our base cases. We'll check if n is equal to 0. If it is, we'll return 0. We'll check if n is equal to 1. If it is, we'll return 1. We'll initialize a variable called sequence with an array containing our 0 and 1. We'll initialize a counter with a value of 2. We'll set up our while loop that will run while counter is less than or equal to n. The first thing we'll do inside of our while loop is grab the next number, which is the sum of the values in the sequence array. Then we will assign the value at the first index to the 0 index. Next, we'll assign our next number to the first index. And then we will increment our counter by 1. Then when the while loop exits, we will return the sequence first index. And that is our solution. Let's save this and run it against our test cases. And we get the expected output. Let's copy and paste this in a Leetcode. Okay, let's paste it in here. Hit submit. And we get an accepted solution.